Hello everyone, I am Sankarshan in entry number 2021EE30175 of Group 15 and I present to you my ELL101 project. And today, the topic of my project is mobile charger. All of us are surrounded by mobile phones and especially after the pandemic, phones have become a necessity. We use phones so much that we often need to recharge it. We do this by a relatively simple yet complex device called chargers. So, this is a picture of a regular mobile charger. Today, we will look into the circuit of a rather simple one, not as complex as the one we use in our daily life, like this one. Now, components required for our circuit are input supply of 220 volt, diodes, capacitor, one of 1000 microfarad and another of 0.01 microfarad, and a voltage regulator IC7805. So this is our circuit. Now, first we take a 220 volt input supply and supply it to the circuit. The input supply is supplied across a combination of diodes which act as a full wave rectifier. So, we convert the AC supply to DC supply with a time period of T by 2. A full wave rectifier is a rectifier that will use 4 diodes or more than in a bridge combination. A full wave rectifier system consists of 4 diodes and a load. This is the circuit for a full wave rectifier. We apply an AC across the bridge. During the positive half cycle, terminal 1 will become positive and 2 will become negative, and the current will flow from 1 to 4 to 3 to 2. This will cause the diodes A and C to become forward biased. The current will flow through it. Meanwhile, diode B and D will become reverse biased, and the current will flow from 1 to 4 to 3 to 2 as expected. During the negative half cycle, terminal 1 will become negative and terminal 2 will become positive. This will cause diodes B and D to become forward biased and will allow current to flow through them. At the same time, diodes A and C will become reverse biased. Hence, the current will flow from 2 to 4 to 3 to 1. As we can see in the negative half cycle, the current flows from 2 to 4 to 3 to 1. So, we apply an AC input as shown in the first one. When the current flows from diode D2 and D3, we will get the signal as following with the time period of T. And when the current will flow from diode D1 and D4, we will get another half cycle. And the combination of both of these cycles will give us the total output voltage with a time period of T by 2 as shown in the figure. So now the capacitor C1 is used to filter out the signal as we do not want an oscillating signal but rather an almost constant signal. So this will be the output after applying the filter capacitor. As you can see, the output has become almost constant when filter is applied. Now the filtered input signal reaches the voltage regulator IC7805. A voltage regulator IC7805 is used to provide a regulated 5 volt DC input voltage. This is the image of a common IC7805 which is available in the market at a very cheap price. Here is the circuit diagram of IC7805 which consists of a combination diodes, capacitors and a fuse. Some important points regarding it are: the input voltage should always be greater than the output voltage by at least 2.5 volt. Second is the input voltage and the output current are almost identical. This means that if we apply 7.5 volt 1 ampere supply as an input, the output will be a 5 volt 1 ampere, which will have a gap of 2.5 volt. The remaining power dissipated as heat. So we require a heat sink as the heat emitted can damage our circuit. Now we get a 5 volt supply. We use another capacitor to eliminate the noise due to the transient changes in the voltage. And we get an output constant 5 volt to charge our mobile phones, and hence now we have a charger which we can use to charge our mobile phones. So we used the simple electrical devices which were taught to us in class to construct a very complex mobile charger. Thank you.